This is Robert Capetta from the University of Illinois at Chicago, and this lesson is on power series, part 2. We want to find the interval of convergence and the radius of convergence for that power series. The sum as k goes from 0 to infinity of negative 1 to the k times x minus 2 to the k over 7 to the k. K is 0, negative 1 to the 0 is 1, x minus 2 to the 0 is 1, 7 to the 0 is 1, just 1. If k is 1, negative 1 to the first is negative 1, x minus 2 to the first, x minus 2, 7 to the first, 7, so negative 1, x minus 2 over 7. If k is 2, negative 1 to the second is positive 1, x minus 2 to the second over 7 to the second is here. If k is 3, negative 1 to the third, negative 1, x minus 2 to the third over 7 to the third, etc. And our goal is to find out which values of k will enable this to converge. That's what we're looking for. Let's recognize that this is a geometric series. Now our first term is 1. What's the common ratio? To get from here to here, we multiply by negative x minus 2 over 7. To get from here to here, also multiply by negative x minus 2 over 7. From here to here, multiply by negative x minus 2 over 7. So the common ratio is the negative of the quantity x minus 2 over 7, and our first term is 1. And when does a geometric series converge? That will happen when the common ratio is between negative 1 and positive 1. So I will need this value to be between negative 1 and positive 1, and what those x values are will define our interval of convergence. So there's our r value, opposite of x minus 2 over 7, between negative 1 and positive 1. And we need to simplify that inequality to determine our interval of convergence. And just a quick point here, for a geometric series, if r equals 1, the series diverges. If r equals negative 1, the series diverges. So in this case, we do not have to check the endpoints, but in other cases, we do. Here we go. If we're trying to simplify this inequality, we're going to multiply both sides by 7, or all sides by 7. And we'll get negative 7 is less than the opposite of x minus 2 is less than positive 7. Multiplying by 7 does not require us to change the signs, but we're now going to multiply by negative 1, multiply this piece by negative 1 and that piece by negative 1. If you multiply both sides by negative 1, you've got to switch the sign. Same thing here, this side by negative 1, that side by negative 1 requires us to switch the sign. So we'll get 7 is greater than x minus 2 is greater than negative 7. Now we're going to add 2 everywhere. Adding 2 does not require us to change the sign. 7 plus 2 is 9. Negative 7 plus 2 is negative 5. So we have 9 is greater than x, which is greater than negative 5. That will give us our interval of convergence. Our interval of convergence will go from negative 5 to 9. The center of this interval is 2, and you can sort of see that up here. That's our center. The center of that thing is 2. In between negative 5 and 9, the middle of negative 5 and 9 would indeed be 2, and we see that here. The radius of convergence is 7. The radius of convergence is half the length of the interval from negative 5 to 9. That has a length of 14. So the radius is half of that. Where do we see 7 in our discussion here? Well, the 7 is there. That's going to help us get our radius of convergence, as well as seeing the 7's there. So the center is the midpoint of the interval of convergence. The radius of convergence is half the length of the interval of convergence. So as you see those terms, that's a way to think about those. Our next question will be to find the interval of convergence and the radius of convergence for this power series. Sum as k goes from 0 to infinity of x to the k over k factorial. It's always a good idea to get a feel for what it means. So if k is 0, x to the 0, 1 over 0 factorial, also 1, 1 over 1. If k is 1, x to the 1 over 1 factorial, or x to the 1 over x. K is 2, x to the 2 over 2 factorial. K is 3, x to the 3 over 3 factorial, and you see the pattern. This goes to infinity. This is a power series. It goes on forever. We want to find out what the interval of convergence is for this power series. We're going to go ahead and use the ratio test. And what do we want there? We want the limit as k goes to infinity of a sub k plus 1 over a sub k. I prefer to think about it in terms of the absolute value. So the absolute value of a sub k plus 1 would be the absolute value of x to the k plus 1 over k plus 1 factorial. The absolute value of a sub k is the absolute value of x sub k over k factorial. So we're interested in the absolute value of a sub k plus 1 divided by the absolute value of a sub k, which would be x to the k plus 1 over k plus 1 factorial divided by absolute x to the k over k factorial. Inverting and multiply times k factorial over absolute x to the k. Well, k factorial divided by k plus 1 factorial results in a k plus 1 downstairs. Absolute x to the k plus 1 over absolute x to the k leaves us one more absolute x upstairs. That is our result. Now, what is the limit as k goes to infinity of absolute a sub k plus 1 over absolute a sub k? Limit as k goes to infinity of absolute x over k plus 1. Fine. We can pull the absolute x out in front, times the limit as k goes to infinity of 1 over k plus 1, which is absolute x times 0, which equals 0 for all x. And remember, for the ratio test, we have convergence when that limit is less than 1, and 0 is less than 1 for all x. That means no matter what x is, this will converge. So we could say here that our interval of convergence is all real numbers. Now, it doesn't make a whole lot of sense to talk about a center if it's infinite, nor does it make a whole lot of sense to talk about the radius of convergence. But the radius of convergence is half the length of the interval of convergence. Well, the interval of convergence is what? Minus infinity to infinity. So it's half that. Still, radius of convergence would be all real numbers too. So the radius of convergence, I guess we would say, is infinity. So this is a little bit better way to say it, I guess. If the interval of convergence is infinite, then the radius of convergence has to be infinity, from the center to infinity in one direction, from the center to negative infinity in the other. And that will conclude this lesson.